Hi, I'm Lerna. I'm a solutions engineer at Clockwork, and welcome to our product overview. For AI workloads at scale, compute is no longer the bottleneck. Communication is the new bottleneck. If you were to profile a distributed training job, you would see that it goes through cycles of compute followed by communicate. And the flows in these workloads are highly synchronized. They run over thousands of links and transceivers in these GPU clusters, and a single link flap or congested path can slow down the entire job. So if you look at GPU clusters today, they only deliver at most 55% of their peak theoretical performance. AI fabrics, on the other hand, they bring their own challenges to the infrastructure teams that have to support them. There's a separate backend network and a separate front-end network. The workloads themselves are highly demanding, and they have low tolerance to latency and jitter, for example, and frequent GPU and network failures, they cause jobs to restart. For example, at Meta, they had to restart jobs over 450 times in less than 2 months while training Llama 3, and that's a lot. Now, working with neoclouds and enterprises, at Clockwork, we see an AI efficiency gap for AI infrastructure at scale. First, there's a visibility gap. There's a lack of ability to correlate workload performance like step time and time to first token with infrastructure issues such as GPU or network card or cable or a switch that is causing the actual issue for the workload. Second, there's a reliability gap. Network cards and links flap in large enough clusters, or entire nodes fail and interrupt jobs, and it forces the jobs to restart. Finally, there's a performance gap. There's contentions on shared flows that slow down inference and training, or you may need performance isolation, for example, when it comes to prioritizing storage traffic versus application traffic. And all of these gaps together, they result in lower GPU utilization and longer job completion times. Now, we said communication is the bottleneck that slows down AI networks and AI workloads. These workloads, they have stringent I/O demands. They have synchronized GPU to GPU flows and stateful flows for storage I/O. They run over multiple networks and transports, whether that's Ethernet or RoCE or InfiniBand. If you look at the operators, they are forced to manage many different networks and protocols and libraries, anywhere from libfabric, IB verbs for the network APIs. And if you look at communications libraries, there's Nickel and Rickel, or MVishmem and MPI, and all the way up to the workload. And if communication slows down at any one of these layers, then overall performance degrades and model flops go down. Clockwork closes this gap with Fleet IQ, that is our software-driven fabric. First, our ClockSync technology aligns all the clocks to a common reference at sub-microsecond accuracy. This lets us measure one-way delays anywhere within the stack, so that you can tie fine-grained network telemetry directly to application performance. And this provides cross-stack visibility. Next, Fleet failover with stateful fault tolerance against NIC and link flaps that provides resiliency so that the jobs withstand these failures without any restarts. Finally, dynamic traffic control. It rebalances traffic to avoid contention. It paces flows intelligently to prevent congestion like incast or increased tail latencies to workloads. And it provides ability to partition bandwidth across different flows based on their priority. This is software. It runs anywhere. It runs across diverse GPU environments, InfiniBand, Ethernet, or RoCE. It is vendor agnostic. It doesn't have any reliance on proprietary switch features, for example. This way, it provides deep visibility, resiliency, and performance acceleration for GPU clusters and AI workloads at scale. Now, if we look at visibility, we have 3 modules here. So we have Fleet Audit, Fleet Monitoring, and Workload Monitoring. Fleet Audit itself is a comprehensive cluster validation check. It is a 5 to 10 minutes intensive test suite that verifies software configuration, that runs checks across front-end and back-end network when it comes to latency and throughput, for example, and nickel performance. And it provides actionable insights for both cluster operators and workload owners. Fleet monitoring provides out-of-band telemetry with real-time insights into the link failures in the GPU cluster. Any topology at runtime, it surfaces congestion and contention issues in the cluster even when there are no workloads running. Finally, workload monitoring is an in-band telemetry that is in the data path. It's for the workload at runtime, giving real-time insights into the flows for the workload itself and correlating the job and network metrics so that you can identify and resolve issues quickly. Fleet IQ, that is our software-driven fabric. It delivers deep visibility, performance, and resilience so that AI jobs can run without interruptions, they complete faster, and AI clusters are performant and reliable at scale. Interested in a demo? Contact us.